So undoubtedly, the number one most compelling feature of Oracle Database 12c is the support for consolidation. But now with pluggable databases, they can share now many resources. They can share memory resources. They can still run them on that same computer. And they can make the management easier because it is still a single database instance.
Pluggable databases is a step forward in that. So now that's going to give us more control over our schemas, over our applications, be able to isolate a little bit more.
This will help with customers that are doing traditional schema consolidations and give them an extra layer of security that they wouldn't get from the previous method of a schema consolidation.
You can lower down the costs of administrative needs. So of course, you don't have to install as many software installations and doing the patches during the lifetime of an application.
It allows us to consolidate hundreds of databases onto a rack environment, but guarantee the separation that drove us to put them on separate servers previously.
Well, good morning, everyone, and welcome. I'm really excited to announce the next generation of Oracle's leading database, Oracle Database 12c. This is no ordinary release. We've advanced the state of the art in database technology with innovations that no one else can match. Oracle's been in the database business for 36 years, since our founding, and we haven't even begun to ramp down innovation on the database side at all. In fact, just the opposite. We're constantly accelerating it. And we continue to listen to you, our customers, to really understand requirements and deliver even more than what you asked for, even more than what you thought was possible. Oracle Database 12c is generally available today. It's a breakthrough release which makes cloud computing better, a lot better. It's the first multi-tenant database designed for the cloud. It's fundamentally new multi-tenant architecture enabling you to create multiple pluggable databases to support modern cloud deployments. You get all the benefits of multi-tenancy, such as hardware efficiencies, easier management, fast provisioning, without even having to make any changes to your applications. What's more, you get the data isolation security you need for cloud computing within your enterprise. And there are other innovations too, like enhancements for better compression, storage management, security, and high availability, all of which provide even greater value to our customers. Oracle Database 12c is game-changing, and our early customers agree, describing it as a truly innovative technology that'll make you rethink how you use databases. It's reshaped our business, and it is the foundation of our expanding cloud business. You'll see what we see. The technology innovations in this release will help you lower your IT costs, minimize data center complexity, and be more responsive to your business requirements. So whether you're consolidating databases or getting ready to deploy a private cloud or a SaaS vendor with a public cloud offering, Oracle Database 12c is the ideal platform. Now next, you'll hear from Andy Mendelsohn, our Senior Vice President of Database Technologies, who will go into greater detail on the latest innovations in Oracle Database 12c.
Today, I'm really excited to be able to introduce our latest version of the Oracle Database, Oracle Database 12c. Database 12c is another great leap forward for our database technology. It's the first database designed for the cloud. It's designed to benefit our customers deploying private database clouds, and it's designed for our own Oracle public cloud offering. Plus, it's designed for all the existing SaaS ISVs who deliver their applications via the cloud, as well as the tens of thousands of our non-SaaS ISVs who want to move their applications to the cloud. Oracle Database 12c includes a number of breakthrough game-changing innovations. But the key new feature in Oracle Database 12c is something we call pluggable databases. Just like virtualization lets you turn a physical server into a collection of virtual machines, pluggable databases let you turn a physical Oracle database into a collection of what we call pluggable databases. Each one of these pluggable databases looks and feels to an application like a physical Oracle database. So the application runs unchanged in a secure and isolated environment. Plus, we've got powerful resource management capabilities that make sure each pluggable database gets its fair share of the system resources. For private clouds, This enables easy and efficient database consolidation that's much more efficient in terms of hardware utilization and also ease of management and administration. In the public cloud, this enables support for multi-tenancy in the database tier rather than in the application tier. So for the first time, all the power of an Oracle database is available to the SaaS applications in a secure and isolated fashion. The beauty of pluggable databases is that it's been designed with cloud computing in mind. So it provides all the attributes you need for the cloud, fast provisioning, cloning, good resource management capabilities across all the different databases running in the cloud. Plus, with pluggable databases, we made sure all those great technologies that you know and love with the Oracle database all work in conjunction with pluggable databases. Features like rack and partitioning, active data guard, advanced compression, parallel query, everything works. All the security features work. All of the tools you know and love, they all work. All those BI tools work, etc. And again, no changes to the application are required. And now I'll talk about a couple of other features we've got in the release that I think are really compelling. The first one is something we call automatic data optimization. This feature provides smart data compression and tiering that both lowers storage costs and improves the performance of your databases. We've got major advances in availability and security. Plus, we've got more innovations to support analytics against your big data. Plus, of course, there's 500 more features in the release. It was a massive effort to deliver this release. We did a fundamental re-architecture of the database to do pluggable databases. And at this point, I'd really like to thank the great work from my development team. We put in over 2,500 person years of effort into this release. We've done over 1.2 million hours of testing on this release on a cloud of over 3,000 systems that we use for the development and testing. And at this point, I would like to turn things over to my development team, and they're going to talk to you in more detail about various aspects of the release. Plus, as a special added attraction, we've got Tom Kite, the world-renowned Oracle database evangelist, who's going to give you his top 12 list of the best features in Database 12c.
Companies have tried various approaches to consolidation. They might have tried virtual machines. With virtual machines, you can get a number of different applications running in a single physical server. However, what we've heard from our customers, and a number of independent surveys have corroborated this, is that what you achieve is a reduction in physical sprawl, but you've still got the virtual sprawl, and the virtual sprawl is still expensive to manage. Furthermore, in each of these virtual machines, you're duplicating the overhead of the operating system and the database server for every one of the applications hosted in these independent virtual machines. Let's think about our traditional Oracle database architecture. Every time we create a database, be it a production database, a development or a test database, what do? We create a set of files. We allocate a set of memory for managing the data, and we kick off a bunch of background processes. And this is duplicated for every one of the databases that we create. So the highest degree of consolidation that we can achieve is by hosting all of these applications in a single database server. Pluggable databases are a key component of what we call Oracle multi-tenant, new with Oracle Database 12c. The pluggable databases are self-contained, fully functional Oracle databases. The revolutionary part is many of these pluggable databases can be plugged in to a single multi-tenant container database. This allows us to manage many as one, and this is what allows us to achieve a great reduction in operating expenses, because each of a number of operations are performed at the level of the multi-tenant container database. For example, one backup covers all of the pluggable databases. When we apply a patch, we apply at the multi-tenant container database level, and all of the tenants benefit. Because each application connects to a self-contained individual pluggable database, there's no need to make application changes. Furthermore, just as the individual pluggable databases can be plugged into a multi-tenant container database, they can also be unplugged and plugged into a separate, different container database. This allows us a great deal of flexibility. For example, we can perform an upgrade on a single pluggable database simply by unplugging it from one container, say at version 12.101, and plugging it into a second container database already upgraded to 12.102. With this new flexibility, we can easily move an application from one service level agreement, or SLA, to a different one. For example, if we've got an application running in a pluggable database in an environment which is backed up, let's say weekly, perhaps there are daily incremental backups, but we want to move it to a higher availability service level, we would simply unplug it from the first container database and plug it in to a container database managed at the higher SLA, for example, Oracle Real Application Clusters and Active Data Guard. Simply by unplugging and plugging this database, we've upgraded the SLA for this application, and that's really unprecedented flexibility and agility in operations we're delivering with Oracle Multitenant. With Oracle Multitenant, we greatly simplify the process of provisioning databases. We can create a new pluggable database very simply. It's actually a single SQL statement to create a pluggable database. And furthermore, the process of cloning a database is extremely simple. With certain file systems, Oracle's ACFS, ZFS, and NetApp, we can even do snapshot cloning, which allows us to create a cloned pluggable database in the order of seconds. With Oracle Multitenant, we provide great facilities to allow for the management of the contention of resources between these different applications. One can simply define policies in terms of caps and shares that allow us to control the way, for example, CPU and Exadata I/O are allocated between these different pluggable databases hosted in the same multi-tenant container database environment. With traditional approaches to consolidation, there's typically been a trade-off between reductions in capital expense or operating expenses, and it's always come at the cost of agility. With Oracle Multitenant, we allow reduction in capital expenses, reduction in operating costs, and a great increase in agility. And most importantly, you can adopt Oracle Multitenant with no application changes required. Oracle Multitenant is a very flexible architecture, and we see many different use cases that our customers might be able to take advantage of. A great use case for Oracle Multitenant is development and testing. Many of our customers have decided to start here because the very engineers that they want to become expert in the new technology would be using it in their day-to-day work. In development and testing, the requirement is typically rapid provisioning and recycling of databases, and the new capabilities of Oracle Multitenant with cloning, even snapshot cloning, make this extremely efficient. Another use case is what I call consolidation of disparate applications. In this, we simply take separate, self-contained pluggable databases, one for each application, and plug them into a single multi-tenant container database and run the whole on a consolidated server. Software as a service, or SaaS, is another good use case. In this environment, you have multiple copies of exactly the same application system used by various different tenants on the cloud. With Oracle Multitenant, you can manage all of these tenants at once, but provide the isolation and security requirements between these tenants as is required, and each individual tenant connects to the application as if it were a single isolated database. With Database as a Service, our customers are typically trying to deliver standardized services in the cloud. Their users will identify from a standard set of database sizes, provision that database, and plug it into a container database managed at the appropriate service level agreement. With Oracle Multitenant, this is extremely simple to provide. Another great use case addresses a typical problem of many independent software vendors, or ISVs. That is, how do you first install this application at the customer's site? The process is quite long-winded. They have to create a database, they have to build a schema, they have to install a load of seed data. Well, with Oracle pluggable databases, the ISV simply delivers the application as an unplugged pluggable database, delivers it to the customer, who then simply plugs that database into a multi-tenant container database at their site, and there is the application ready for use. Oracle Database 12c is the first database designed for the cloud. With Oracle Multitenant, we can deliver all of the advantages of consolidation with none of the disadvantages that were inherent in the other approaches that have been tried. We allow great reduction in capital expenses because of a very high level of consolidation that's achieved by sharing the database overhead between multiple pluggable databases in a single multi-tenant container database. We achieve massive reductions in operating expenses because we allow many databases to be managed as one. While managing many as one, we retain granular control where appropriate, and this gives us the flexibility to operate efficiently in the cloud. Most importantly, to adopt Oracle multi-tenant, no application changes are required. So with Oracle multi-tenant, new in Oracle Database 12c, you can plug into the cloud.
Storage in the database has an interesting history. Customers have traditionally used one tier of storage for their databases, and it's their most valuable data that they're putting in the Oracle database, so they of course spend the most money on storage for the database, and what people typically call tier 1 storage. And so most customer databases even today are still primarily on one tier of storage, usually the most expensive tier, the most high performance tier. What's been happening is those databases have been growing faster and faster, essentially growing at an exponential rate. And it's becoming less possible, less affordable to just keep on buying more tier 1 storage when the amount of data you have to store in your database is growing so fast. And so the challenge is, okay, how do I figure out what parts of my database should stay on my tier 1 storage, what parts I can keep online but move to some slower, cheaper, denser tier of storage where at least it's online, but the performance isn't as good, but it's still available when I need it. In past database releases, we've implemented a number of different features to help customers manage storage. Partitioning lets you transparently segment the data in a table, usually your larger tables, so that each partition can be managed independent of the others. So you can put each partition on a different tier of storage if you want to. You can actually compress each partition separately with different compression algorithms, depending upon the workloads. Another important feature is ASM, or automatic storage management, which makes it easier to optimize how data is laid out on a set of disks, so that you get all the performance of striping data across all your disks, and all the availability characteristics of using mirroring to ensure that a single disk failure doesn't result in any loss of data. There's a number of compression features in the Oracle database that we've added over the years. The advanced compression option, which actually has about 5 different features in it to help you compress table data and unstructured data and RMAN backups and data pump exports and data guard traffic. And also in 11G Release 2, we added hybrid columnar compression. Originally, it was part of Exadata only. More recently, we extended support for hybrid columnar to ZFS storage appliance and Pillar Axiom storage. And as the name implies, hybrid columnar uses a column-based format for storing data, which delivers 2 things that is much harder to do with a row-based format. Column-based format gives you the ability to get higher compression ratios because you're storing all the data for a column together. So all the data is by definition of the same data type and often very similar values. So it's easy to get higher compression ratios. And columnar format helps greatly improve the performance of analytic type queries, business intelligence type queries that scan lots of data. Columnar format helps with performance of those types of queries. You can use partitioning and compression, both advanced compression and hybrid columnar, to do a lot of what you want to do. You want to do storage tiering, you want to compress data more aggressively based upon how cold or hot it is. But you have to figure out manually when it's okay to move a given segment of data to a slower, cheaper, denser tier of storage, or to move it to a more aggressively compressed format. It's up to the DBA or the system administrator to figure out when it's okay to move data. And so it is still mostly a manual process with 11G Release 2 even. With Oracle Database 12c, we've added capabilities that make it easy to automate the movement and compression of data. And those 2 features are the heat map and automatic data optimization. And the heat map, as its name implies, The database keeps track of when data is accessed, even to the level of detail of keeping track of modifications, insert, update, delete, separate from queries, from full table scans, and even index lookups. So we distinguish those three types of access, and it's tracked even at the block level in the case of modifications. But we track it at the block level and at the table level and at the partition level, all automatically, so that the heat map gives you deep insight into exactly what data is being accessed and what data is not being accessed. How cold is the data? How cold is a partition? How cold is a block? And that's great. So you've got this heat map. Automatic data optimization is a simple declarative policy-based way for you to tell the database what to do with data based upon how cold it is or how hot it is. And so all you really do with ADO is to define these policies on your tables, and then the database will automatically move data around as it qualifies based on your policies. The daily work of a DBA and a storage administrator, system administrator, we think is going to change quite a bit with the use of the heat map and automatic data optimization, because before the heat map and automatic data optimization, they had to write scripts and jobs and constantly be updating those scripts and monitoring the jobs, make sure they're running correctly, to move data around, to implement tiered storage and compression tiering. With automatic data optimization, it's a lot easier. They simply create these declarative policies, and then they can monitor the database automatically moving the data around. So there's just a lot less work for them to do to implement the storage plans, essentially the information lifecycle management policies they want to implement. And this lets them save a bunch of space and improve performance. Since we've integrated it up and down the stack in the Oracle database, we actually see significant improvements in performance. Not a slowdown in performance, but a speed up. And so tie it all together, you save space and improve performance, and in 12c you do it all automatically. So the DBA in 12c will now be able to, with some simple policies, implement storage tiering and compression tiering that will save his company a lot of money on storage and at the same time actually improve performance. We don't see anything from the database competitors that do anything like this. Some of the storage vendors have implemented some automated tiering, automated storage tiering capabilities. The problem with those capabilities, of course, is that they're not database aware. From the perspective of what we see competitors, we haven't seen anything like the heat map from anybody in the database world. And even the storage tiering from the storage array vendors, it's blind as to what the database is doing.
From the database development perspective, we have taken a look at all these problems that the customers have had trying to assemble an high availability architecture from this mishmash of technologies. And we decided that the best approach would be an integrated holistic approach towards high availability. So we have several capabilities integrated right within the database, and all of these capabilities are manifested through an architecture that we call maximum availability architecture, that is MAA. The fundamental building blocks of MAA are technologies such as RAC, which is our active-active clustering solution, technologies such as DataGuard, which is our data protection and DR solution, technologies such as Golden Gate, which is our logical replication solution, helps in migration also, and several other technologies that are inherent with the database, such as RMAN for backup and recovery, Oracle Secure Backup for tape backup, Flashback database for human error-related correction, ASM for integrated volume management. Oracle Database 12c from a high availability perspective as a whole suite of new features. That would be a whole separate 1 hour to 2 hour conversation. But if you ask me to pick a few of those to see or to better understand how we address some of those, I can talk about, say, for example, global data services, which global data services allows us to run an Oracle database service anywhere within the data center, across data centers, across regions, across geographies. That is, the service may not necessarily be tied to a data center asset, as long as the databases are synchronized with each other. And of course, we do the synchronization through established technologies such as Active Data Guard and Golden Gate. And the beauty of this is you run this database service, applications simply connect to the service without really needing to know which data center or which physical infrastructure the application is connecting to. So this is really what's enabling a unified, consistent Oracle Data Cloud. Imagine a customer, a financial investment company. This financial investment company has a database in Europe, has another synchronized database in Asia. Okay, at various times of the day, clients could be connected to the local database. So for example, the European database could be connected to, the European clients could be connected to the European database, and the Asian clients could be connected to the Asian database. Because of additional activity, the European database is highly loaded up. Or for example, maybe there is a hardware fault and the database is brought down. So at this point, the last thing you would want to do is to send additional connections to the European database. What happens if you send additional connections to the European database? Those connections will be stalled, right? And in the financial world, that's the last thing you want. Ideally, what you would want to do is to route those European connections to the Asian database. That's where Global Data Services or GDS comes in. It allows this transparency. It allows this transparent access to this data cloud without the application needing to know. It just takes care of the load characteristics, the failover characteristics, and also it takes care of any specific business policies that you may want to configure based on your data access requirements. The second solution is it's very near and dear to many of us web consumers. When we are shopping in, say, Amazon.com or any other internet site, frequently you would see a notification at the end saying, press the submit button only once. The history or the context behind that message is, if you press the submit button, basically the web server gathers up your data and sends it off to the app server, and then the app server sends it off to the database server. So your request is traversing the IT stack. When it comes to the database, the application server could be issuing a whole bunch of database requests. And if something goes wrong in that IT stack, maybe a hardware fault or a software fault or maybe performance characteristics, there is no easy way for the application to figure out whether the previous operation succeeded or not. So while the application is thinking about that, if a second submit button comes in, the application will have to reissue the entire request, leading to your credit card issued or charged twice. What we have done in the database infrastructure layer offered this feature called application continuity that basically takes care of the situation. It says that, okay, it does not matter what fault happens in the database layer or in the IT layer surrounding the database, as long as those transactions are recoverable. The database will transparently replay those transactions and get the results back to the application. And not only that, we also have an API through which the application can simply query and say, okay, give me the state, give me the result of the last transaction. Based on that, then the application can take corrective action. Any application accessing the Oracle database now, that is Oracle Database 12c, doesn't have to involve or get involved in manual cumbersome coding around handling these errors. The database just takes care of it. If I go down the stack, that is in the storage layer, in the data bits layer, a big issue that customers have to deal with is data loss. And this issue is very relevant in disaster situations. Mind you, I use the word disaster, and that word disaster could have connotations such as a natural disaster or a man-made disaster. But if you are involved with data center operations, you know that in the data center world, every day there are these small disasters which don't make the newspaper headlines. Still, they're equally impactful. For example, a local power outage. For example, somebody tripping over a network cable. When this happens, often customers use our technologies related to data guard. However, for wide scale or a wide area network deployments of data guard, say for example, we are looking at a deployment between US East Coast and the US West Coast. Frequently, or in most cases, customers have to implement what's called an asynchronous solution. That's just because of the network latency. If you want to implement a synchronous solution, there will be too much impact of a network latency for wide area distances. However, to guarantee or to assure a zero data loss solution, you need a synchronous configuration. In other words, they cannot deploy a zero data loss solution. So if something were to happen to the New York database, you fail over to the San Francisco database, yes, the failover works fine, but the New York database may still have the last bits of data which it had not yet sent to the San Francisco database, leading to some data loss. Now, depending on the recovery point objective requirements of customers, this could be okay because that's what the business policies say. Some other customers may say, no, I want absolute zero data loss under any circumstance. With this new capability called DataGuard FastSync, we have enabled a zero data loss Oracle optimized solution for wide area DR configurations. And that's really a big deal. We have done it in a way such that there is no performance impact. On top of that, customers get a zero data loss solution. So that's really a combination of best of the both worlds. No performance impact and the best data protection. And we have done it in a way that is very nicely optimized for the Oracle environment. The biggest benefit of some of these features of Oracle Database 12c that are related to availability is we try to minimize or eliminate making these choices, making these compromises. If the customers want to do availability, if they want to implement an HS solution, they don't have to give up on something else. And that's what we have made sure, that when they have embraced our solution, they are not giving up on anything else, whether that's security, whether that's performance, whether that's scalability. From a thematic standpoint, that's the real benefit that stands out.
As a leader in database technology, Oracle revolutionized database security by introducing transparent data encryption, virtual private databases, and privileged user controls. With Oracle Database 12c, we have undertaken the most ambitious security project ever. We introduced many new features, including data redaction, privilege analysis, conditional auditing, and real application security, which would change the way people would be securing their databases. While encryption allowed customers to protect their data while within the database, they were looking for solutions to really redact the data when the data reached the customer's endpoint. So for example, if they have sent a query for a customer record, they may want to see all information except for the credit card data. There are many existing applications out there where existing reports may be showing users' date of birth, users' privacy information such as social security number or credit card numbers. And we don't really want to show all of that data to some regular end user, maybe a call center person, or as part of some warehouse report. But you can't really go back and change your application for that. You can't go back and change your data within the database. What you really need is on-the-fly redaction as it goes out from the databases. So we added this feature called Oracle Data Redaction, which redacts the data on the fly as it reaches the end user's desktop without having to change your application. We keep the data the way it is inside the databases, but through a policy, redact the data at runtime based upon who the user is. One of the challenges that people have with security is that most of their applications and accounts are overprivileged, which means that at one point of time, you may have been granted a lot more powers than what you actually really needed. Which means that if you are attacked or your account is hacked into, somebody could use all those powers to get to a lot more data. So what you really want to do is to take those things away, but you don't really know what to take away. So to accomplish that, in Oracle Database 12c, we introduced privilege analysis that allows you to analyze all the roles and privileges that you have used during the execution or completion of a specific task. So once you know which privileges and roles you were really using, you can then go back and ensure that you only have the required roles and privileges to do your job. Thus, we're really improving the security posture of the entire database by ensuring the least privilege for all the accounts, whether it's the application or the user. Today, to do auditing, you have to list every specific statement that you actually want to audit. And you don't really have a way to turn it on conditionally. And now with Oracle Database 12c, we introduced conditional auditing, which allows you to group all of the audit statements in one policy and then apply conditions to it, such that, for example, you can say that I only want to audit a specific user at a specific time using a specific role, and you get only what you're really looking for, so that you can then act upon it and really not have to spend a whole bunch of time analyzing them. In the past, while building your own applications, you would typically enforce the security of the application inside your middle tier. With Oracle Database 12c, we have introduced real application security, which enforces the application security right within the database based upon the user information. Customers want to look at not only what's happening inside the database, but they also want to be able to control who's coming in from outside. A solution that allows them to track the activities of their privileged users. Customers are looking for a flexible way to look at what's happening inside the database and to look at the SQL statements that are coming into the database. So both an inside-out security combined with the outside-in security. And they want this flexibility to be able to do it for Oracle and non-Oracle databases. Oracle Audit Vault and Database Firewall does activity monitoring, does blocking, and auditing for Oracle and non-Oracle databases. And this time, we also added support for auditing of the infrastructure surrounding the databases, which is your operating system, your file system, and directories, all in one combined solution. So Oracle Audit Vault and Database Firewall offers a comprehensive security solution that provides both detective as well as preventive control for Oracle and non-Oracle databases. So Oracle Database 12c offers the most comprehensive security features: preventive controls, detective controls, and administrative controls.
I'm here today to talk to you about 12 things about Oracle Database 12c, the latest generation database technology from Oracle. This was hard to put together because I had to start with a list of over 500 new things inside the database. I whittled that down to about 80 and then kept sorting and resorting that and came up with 12 features that run from the simple to the really high end. So for the first one, it's even better PL SQL from SQL. Starting in 12, you'll have the ability to start a SQL statement with a bit of PL SQL code. So you could go with function f is and define the body of a function and have it be compiled into the SQL statement basically, rather than having to compile it at the command line and grant permissions on it and have it be a persistent schema object inside your database. So even better PL SQL from SQL. Number two, some improved defaults. For a long time, I've wished that we could default a database column to be populated by a sequence number. Well, now in Database 12c, you can in fact do that. Not only can you default a column to be populated by a sequence.next file, but you can use a new data type of sorts. It's called an identity. So you could declare some column to be an identity type and will automatically create the sequence for you and populate those values. And of course, you have control over the sequence values that are generated as well. In addition, we have the ability to have a column that defaults to a value on null. So in the past, if you had a default value, it would only be used if you didn't put that column in the insert at all. Now you can put that column in the insert, and if you insert a null value, we'll supply a default for it. Additionally, in the area of improved defaults, you can now fast add a column with a default value, even if it's nullable. In the past, if you added a column with a default value and it was not null, we could add that in milliseconds because we didn't really have to touch the data. Now we've extended that to any column that you add with a default value, regardless of whether it allows nulls or not. Next, number three, increase size limits for some data types, specifically varchars, nvarchars, and raw data types. So I remember way back in version 7.3, columns had a maximum width of 255 characters. In 8.0, we extended that to 4,000, and that seemed like a lot at the time. But over the years, our needs have changed, and so has the size of this data type. Now in Oracle Database 12c, a varchar can go up to 32K, just like it can inside of a PL SQL block. So now we have better parity between the PL SQL types and the SQL types. Number four, easy top-end and pagination queries. This is something people have been looking for a while. I've written no less than 3 articles in the magazine on how to do top-end queries and pagination queries. It's a question that comes up frequently. In Oracle Database 12c, there's a new row limiting clause, similar to the ones you might have seen in other databases, but it allows you easily to say, run this query and give me rows 5 through 10. Give me rows 100 through 120. So it will make getting the top 10 records, the top N records, and just paginating through a result set pretty easy. Number 5, row pattern matching. Many times our data has patterns. Think of stock quotes, for example. People are looking for V patterns or W patterns in that data. That is, they're looking for a series of rows where the stock price started at some high value, and over time it decreased, hit a bottom value, and then started to go back up. That would be a V pattern. A lot of times people might want to buy on the double dip. They want to buy on the second part of that V, the W shape. Well, now inside of SQL, you can set up a pattern matching clause that, using a regular expression like syntax, you can describe to us the pattern that you're looking for in the data. So you can look for those V's, you can look for those W shapes inside of the data as we're streaming through the rows. Number 6, lots of partitioning improvements. Things like the ability to do multiple operations on multiple partitions simultaneously inside of a single DDL statement. In addition, we have the ability to do reference and interval partitioning together. Another great enhancement is the ability to move a partition of data online without having to use DBMS redefinition. So you're able to move a partition from one set of storage to another, maybe to compress it, maybe to move it to cheaper storage, while that table is online, while people are still transacting against that data. Lastly, the ability to have asynchronous maintenance of global indexes against our partitions. So with asynchronous global index maintenance, you have the ability to perform the partition operation, say a drop or a truncate, and then in the background later, when there's time available, we will come along and clean up that global index. So you can drop the data, but still have continuous query capability against all of your data. Number 7, adaptive execution plans. This is the ability for a SQL plan to sort of change its mind halfway through its execution. With the adaptive execution plans, we can really have 2 plans inside of one, so that as the optimizer, as the database is running that query plan, it can evaluate how many rows it actually retrieved from a step in the plan and decide whether it wants to continue using the nested loops or if it wants to switch into a hash join. So the query plan has the actual ability to adapt at runtime. We don't have to make a mistake and then figure out we made a mistake. We can, while we're running that query, figure out that, hey, what we were thinking about doing is the wrong idea, and switch the plan right then and there. Number 8, enhanced statistics. There's a lot of advancements in statistics inside of Database 12c. So for example, there's a new kind of histogram. There's actually 2 new kinds of histograms, and they deal much better with covering sets of data that have more than 255 distinct values in a column. In the past, if you had more than 255 distinct values in a column, the only thing we could do is give you a height balanced histogram. That had certain issues with certain types of data skew. For example, if you had a column that had some really, really popular values and some really, really unpopular values, but then a whole set of columns that were nearly popular, they had lots of values, but not nearly as much as the really popular columns, we could come up with some really bad cardinality estimates based on the way they were fit into the histogram. Well, with a new type of histogram in Oracle Database 12c, we can better cover those unpopular, almost popular, and very popular columns. Additionally, we have the ability to automatically compute statistics during your data loads. So if you do a create table as select or a direct path load into an empty table, we'll have automatically computed statistics for that during the load so that you won't have to come back and do that. Number 9, temporary undo. When people started using global temporary tables, they were very surprised to discover that temporary tables, which are in temp, generated redo, which is for persistent objects. The reason they discovered is that temporary tables generate undo. They have to generate undo because we have to be able to roll back an operation against a global temporary table. We need to support consistent reads against those temporary tables. So they need undo. By generating undo, however, they needed to also generate redo to protect that undo information in the undo table space. Well, starting in Oracle Database 12c, we have the ability to store the undo for temporary tables in the temporary table space itself. This is going to be great for sites that are running things like DataGuard, for example. We won't have to ship the undo for temporary information from the production site to the standby site. If you're running in archive log mode, it won't be part of your backup anymore. It will be in the temporary table space. And additionally, it will make flashback query and flashback operations in general even more useful because the only information that will be in the undo table space is the information for your data. And for number 10, we have some new data optimization capabilities. Typically, these are known as Information Lifecycle Management, ILM capabilities. But the database is now generating a heat map for our tables. So down to the block level, it's remembering what blocks are being read and written frequently, which blocks are just being read, and which blocks are not being read very much at all, if at all, and never being written to. And we're associating a temperature with these three types of database blocks: hot for the read-write, warm for the read-only, and cold for the hardly ever read. Now, we have the ability to, in a declarative DDL fashion, describe to the database how we'd like to deal with these blocks or treat them. So, for example, we might want to set up a policy, a declarative policy that says hot blocks, we want to use OLTP compression, maybe get a 3-to-1 compression rate on that. Those warm blocks, we'd like to move that data out of the hot and put it into a place where we're getting query compression against that. Maybe we're getting a 10-to-1 compression ratio. We're still reading it frequently. We're not writing to it very much, if at all, so we'd like to compress it even more. And then later on, maybe after it's been in that warm segment for 30 days and it's become cold, we might move it into an archive compressed location inside the database. And so here the DBA, instead of setting up scripts to move this data around on a time basis, is setting up a policy that describes hot, warm, and cold to us, and then another policy declaratively that tells us what to do with this information as it becomes warm and cold. You know, move it from here to there, compress it to this level, and so on. So it's more of a declarative approach rather than scripting and running on a schedule. Next, number 11, application continuity and transaction guard. These are two features that sort of work together. Transaction guard is the ability of the database to ensure that a transaction happens at least once and at most once. We've all been on websites where you fill in the form, put in your credit card number, and hit the submit button, and it says, don't hit that button again, otherwise we may charge your credit card twice. Transaction Guard is designed to remove that from reality so that you don't accidentally order 2 sets of flowers, that you don't accidentally order 2 plane tickets. With Transaction Guard, the application can make it so that they know whether a transaction has actually taken place or not, even if you hit the enter key twice. Building on top of that is a capability called application continuity. This is an extension of transparent application failover, TAF. In the past, with TAF, we've had the ability to transparently fail your application over from one database to another if it was performing a read-only transaction. So if you had processed a couple of queries, generating a report, and the database failed for whatever reason, we could fail your read-only transaction over to another node, another database, and pick it up where it left off. We couldn't do that, however, for read-write transactions. Application continuity allows us to do that for many read-write transactions so that we can pick up your transaction where it left off, replay it, and rejoin you with that transaction in the other node in another database. Last but not least, number 12, pluggable databases. This allows us to basically perform database consolidation on a scale that we could never before. A problem with consolidating databases in the past has been you couldn't take 2 general databases and merge them together into a single database instance. Problems you would run into would be they both have a public synonym that collide with each other, so you couldn't merge those 2 databases together. Or they would use the same schema name, so you couldn't merge them together. Or it could be as simple as the two owners of those databases didn't want their data commingled with the other person's data. My DBA shouldn't be able to see your data, and your DBA shouldn't be able to see mine. Enter a pluggable database. This gives us the ability to run one Oracle instance, a set of processes in memory, and then plug into it up to 252 other databases. These databases all share the same set of processes, so you don't have the 20 processes per database. If you had 100 databases, you would typically have upwards of 2,000 processes for that. If you're using the pluggable database architecture, 100 databases, you'd have 20 of those processes. You have one SGA that all of these databases share. That one SGA will be significantly smaller than the 100 individual SGAs you would have needed otherwise. So this pluggable database gives us an architecture for actually performing database consolidation. Now I just don't dump 30 or 40 databases on a machine and run with it. I'm going to have one database that I upgrade, that I back up, that I recover, that I use DataGuard with, that I configure for rack, but then I can plug in all of these other databases and they inherit all those attributes. So for example, if I've set up a container database that I can plug other ones into and it's in a DataGuard environment, every database I plug into that will automatically have DataGuard provided for it. The backup that I put in place for the container database is the backup that's in place for all the pluggable databases as well. So this really eases the management of multiple databases on a single host. We can even do resource management across those individual databases for the first time. This allows you to put 30 or 40 databases on a machine and actually manage them, resource manage them, backup manage them, DataGuard manage them, and so on. So that was 12 things about 12c. I hope you found it useful and enjoyable. But remember, there's at least 488 other things about the database out there to learn about. So I encourage you to read the What's New In documentation available on otn.oracle.com.
I thought I'd close with a question I get asked a lot. What does the C in Oracle Database 12c stand for? Well, of course, the C stands for cloud, but it also stands for consolidate, compress, control, and then for me, C really stands for customers, because this release was really driven by the requirements of our customers to make the database a great platform for the cloud. Thanks for attending. I hope you enjoyed this in-depth look at Oracle Database 12c. If you want to learn or download this latest release, please visit OTN or oracle.com/database. And if you want to meet some of our experts in person, look for an Oracle Technology Day coming your way soon.
With the pluggable database infrastructure, we can just take our existing database, clone it over in a matter of moments. And with the thin provisioning provided that we can get now with 12c, we're going to be able to use less space, and we're going to be able to return that space quicker.
With the new consolidation method, you can absolutely control the resources you achieve to each different database inside those global containers.
The information lifecycle management with its automation compression features, which made it much easier to age out data, store it on second, third storage level tiers. So that's really great.
12c basically showed me that the advances in the cluster and rack environment are going to give us more stability. It's going to give us more flexibility.
What application continuity brings is that for applications now, they can run in a clustered environment with the security knowing that the Oracle database drivers, in this case, the application continuity capabilities, are going to automatically handle a lot of the failure scenarios.
Oracle data reduction will help us to mass display data where we don't have to modify the application code, so the time to market is a lot quicker and the resources is tremendously reduced to get the application to not to displace the sensitive data.
Another feature that is very valuable to the DBAs is actually the privilege analysis. This is something that we know that people don't always need DBA rights, and this actually gives us proof to dig down and give us exactly the justification for certain rights on the database.